MBT was formed about 8 years ago, along with Tectonic Solutions, and we're here to service the architectural community and provide full technical support when working with through-wall constructions and modern methods of construction. And the materials we all work with are extremely sustainable. And for the purpose of tonight, I've chosen to select Foamglass Cellular glass and introduce it as a product. I'm not sure of who is aware of the material within the marketplace, but we've worked on already some exciting products in Saudi, and I'll continue to work on some really interesting products and buildings. So if I may, I'll run through the presentation now. So the content of this evening will be an introduction of what Foamglass Cellular glass is, an insight into the manufacturing process. We'll talk about ecology and sustainability, the unique properties of cellular glass insulation, and then we can look at various design solutions to augment the architectural community to give them total through-wall construction and roofing solutions, and also a little bit about what we may be able to provide you in technical support. Okay, so the history of the company is actually quite old. We had a patent for the construction or manufacture of cellular glass dating back to 1934. Pittsburgh Corning Group was founded in the USA in 1937, and Foamglass started an industrial process back in 1942. We are now owned in 2017. We were bought by the Owens Corning Group, which is a world leader in insulation, roofing, and fiberglass composite materials. And they have a turnover currently of about 6.8 billion US dollars. We're active not only in the construction industry, which you will see this evening, but also very active in the petrochemical industry, where we offer some unique solutions to the lagging of pipes, shells, and vessels. And when you see some of the unique properties of Foamglass shortly, you'll understand why that would be the case compared to other materials. You can see our history there in Tessenderlo, 64, Glasterstaus, and we recently opened, or relatively recently opened, a plant in China, which purely services the Chinese market on its own. Our headquarters are in Toledo in Ohio. Cellular glass is a unique product. It's made of a closed glass cell structure. It's totally impervious to liquid and water vapor and has many different product types and applications. When we speak of lambda value, that's basically how cool or how warm we want to keep a building, and it comes in various uniform compressive strengths. It's interesting as an insulation material. There are lots of different insulation materials on the market, like mineral wool, polystyrenes, XPSs, which have various properties, but what you will see in Foamglass is a combination of all of these properties in one form. Now, we talk about a sustainable product, and that sustainability starts in the manufacturing process. I'm going to run a video. I trust this is going to work for us, but what I will try and do is describe what we do. We basically produce glass, but 60% of the content of the raw glass that we use is from a recycled source. But to guarantee continuity and quality, we will only use products like car windshields and plate glass. The problem with using other things such as bottles may be the impurity within it. And it is critical for the quality audit that we work with the appropriate material. So here you can see the windshields taken to the plants. And basically the windshields are then ground. They're put into a rolling mill to be crushed and compressed from the shards of glass that you would see. We then also produce the primary materials of glass, which is sand. We run this through an oven. We produce liquid glass, as you can see there, coming through the rolling mills. The liquid glass is then allowed to cool and then is ground into a granular powder. Okay, so it goes through that milling process. What that then leaves us with is a powder. To this powder, we add a product called Carbon Black. We then run it through a furnace to get material to rise. And here you can see a piece of cellular glass being cut in half, halfway through the production process. It's already starting to act as an insulator of glass and holding the product in place. We then go through the energy recovery stage of the product. We cut the slabs to appropriate sizes, and then basically we check everything through cameras. We sample the material. We're looking for compressive strength, ensuring that the material produces to the lambda value that we quote. And then the material is obviously packaged, sorted, and shipped accordingly, which is pretty much a unique manufacturing process, and it doesn't employ a lot of people. Okay, so we're very eco-friendly. The material itself can be used in many guises. So it can be used for roofing, for basements, for various other applications. Okay, excuse me, gentlemen. I don't know whether you've got me there all right. Okay, and can be used in numerous processes, as I say, basements and roofing. The critical thing that you must know about foam glass is it is totally resistant to water and water vapor. So its unit of resistance that one would normally measure is a mu value, and air has a value of 1. Mineral wool is resistant to a value of 1 and 2, so basically it allows for the passage of moisture through the material. Polyurethane, which you think is a hard product, will actually allow for moisture of 50 to 100, and some extruded polystyrenes can rise from 100 to 300. But let's put that in context with regard to our product. When used, it has a mu value which is infinite, which if specified correctly and installed appropriately, means that there can never be any condensation in a construction shrouded in foam glass. So that is a unique aspect to the product. I'm just going to show you a video now, a little bit simplistic, but what it does is it shows the passage of moisture and water vapor through those particular materials we've spoken about. And what you can see is the steam, basically we're boiling water below, and that steam is rising, and you can actually see it passing through the product like perlite, polyisocyanurate. Okay, you can see the steam there formed in the glass. If you look at the foam glass, there's been no transmission of water or water vapor, which is critical in building design and construction. As we insulate buildings more and more, then we have to consider the risk of condensation and moisture. Okay, and if you were looking at the petrochemical industry, everybody, that would be critical around pipes and shells and vessel, because moisture means the risk of corrosion, and corrosion in the petrochemical industry is not a good thing. Okay, so here we also see the reaction of the material to fire. One of the driving issues for all of us, I mean, in principle around the world now, is the fireproofing, fire protection of building, fire and life and safety codes. The advantage of foam glass is it's totally non-combustible. It's an A1 rated material, and you can see a heat source being applied now. Okay, and we're holding the heat source to the foam glass. You'll see a little bit of thermal shock, which is basically the glass cells cracking a little, okay, but no sustaining the flame. Now let's look at a product like polyisocyanurate, which was widely and is widely used. I think the pictures pretty much speak for themselves. You know, in a fire, it tends not to be the fire that gets you, it's the smoke that causes the issues. So we've been very much at the forefront of fire protected roofs and facades for quite a few years now. And we'll touch on that a little bit further. The reason it's so good, it's an inorganic material, it creates no fumes, no smoke release, it's Euroclass A1 non-combustible, it has a calorific value of 0. So, you know, when we look at a fire load, as you will shortly with a full fire test, we're looking to see how that fire propagates, how it spreads in facades, how it moves around the building, through windows and other points of egress and ingress. So it's fairly critical. We have a long life performance against fire. So some insulation materials will claim to check a fire, but actually what happens is the mass of that insulation degrades and it isn't providing the correct form of barrier. So we have a fire barrier per se, because that insulation is retarded and shrunk, the fire barrier doesn't work correctly. So we can prove with tests, with data, that in a situation we can achieve an extra 90 minutes of fire protection on 150 millimeters of cellular glass insulation linked to a masonry wall. Okay, another critical element to the product is the compressive strength. It's surreal, it's made of glass, but it's incredibly strong. Here's an example on a car park deck where we have a lot of loadings, a lot of movement, and to be candid, as you can see here, compared to other products, we're working with a European standard of EN 826. Mineral wool will give you 120 kilonewtons per meter. Plain plastic insulation, 175. Polystyrene, pretty good at 700. But their figures are already based on a 10 to 15% compression. With foam glass, zero compression, 500 to 1600 kilonewtons is available. You can literally build your building off a piece of foam glass, as you will see shortly. So it's ideal in load-bearing roofs, podiums, floors, and other applications. And has been used in the Kingdom of Saudi as well for those applications. The thermal expansion is interesting to note. My background is roofing. I'm roofing with hard metals, copper, zinc, and stainless steel, where we're very conscious of the coefficients of expansion and contraction. But with cellular glass, it's very simple, similar to concrete and steel. If you take a plastic foam, you can see the level of expansion there. And that really, in our region, where the heat temperature is very dramatic and can also cool dramatically overnight, means that you don't need to worry about the rigidity and the structure of the insulant below the membrane that you may be using over the top of it. Okay, so the plastic foam, as you can see, would move and expand, and in fact you would need probably 6 mechanical fasteners to secure the insulant per square meter. In the case of foam glass, we bond it, there are no mechanical fasteners, therefore there is no risk. Okay. It's pest proof and resistant to acid. It was selected for use beneath the Swedish pavilion at the Expo site in Dubai and also the UK pavilion, where we had a serious issue with termites. We have recently done a large project in Oman, which you will see later, where we were really worried about insects burrowing into other insulants, getting into the fabric of the building and causing damage. So mineral wool would support some sort of rodent life, bird life, and other situations in an open facade. So that is one of the things we look at. It's not affected by acid, by hydrocarbons, and another issue, it's impervious to gas and in particular radon, which in certain parts of the world is quite a nasty situation that we need to deal with to prevent the transmission of radon into buildings and into residential developments. Okay, we speak of an eco-friendly insulation. As you saw at the start, our product has no flame retardants. It literally has an element of carbon black in it, contains no propellants, and those propellants are traditionally used in foam materials to get the material to rise. We literally use carbon black and bake our material in an oven like a loaf of bread. Okay, we use a minimum of 60% post-consumer waste glass, and we also are able to partial reuse of our own production facilities. It conforms to a Nature Plus Eco label, gives us very high European environmental label for building products, and we have conformed to very strict criteria. So we have all of the ecological declarations, we're fully audited, even our energy source comes from Norwegian hydro sources, so the basic electricity we use, and you can probably see the various windmills that we use. We're also recapturing a lot of the energy and recycling the energy used in production. Currently, I'm working on the new DEWA headquarters in Dubai, which will be a very large, probably the biggest zero carbon building in the world. And foam glass has been widely specified on that project to get the highest possible green credentials, and will be a LEED platinum building. And you'll see some other examples as we go through. You'll see a lot of the properties that I've spoken about and in this graphic would appear in one or two forms in various insulants. I can safely say there is no other product as an insulation material in the market currently that combines all of the properties of foam glass. So compressive strength, non-combustible, waterproof, vapor tight, ecological, dimensionally stable, with a high thermal performance. Some of the thing as well, it's very easy to work. You can cut it with a traditional handsaw. It's resistant to acid and is pest proof. So our benefit for our customer, be the architect, be the end user, a solid and safe insulation system. It is a future proof. You can load a foam glass roof later on. You can increase the loading that would be trafficked on the roof due to that high compressive strength. It has minimized maintenance costs, and quite frequently we'll see somebody strip an existing 50-year-old foam glass roof, take the waterproof membrane from same, and then they'll increase the thickness of the insulation to get to current norms and put a new membrane over the top. So that gives us a lot of minimized maintenance costs. What I spoke to you before, other insulation products require mechanical fasteners. Over time, corrosion and rot can get to the mechanical fasteners, and then you will have issue with the structure of the building. It is not a case with foam glass, it is a bonded system. And we have examples, everybody, that you can look at, where we've taken cores of buildings that are over 50 years old, and in fact the lambda value is exactly the same as it was declared at the time of installation. There is no other insulant that can give you those properties, which is why we are very confident to give very, very long warranties for the material when used in roofing and cladding applications. So the product in a flat roof system provides insulation and vapor barrier in one application. So we minimize the number of layers. Also, when the first layer of insulation is down, in essence, the building is waterproof and other issue proof, like damage and other trades on site, which enables the fit out contractor to get into the building sooner. It's suited to all types of waterproofing systems, so single plies, hot melt, bitumen, asphalts. It has an incredibly high compressive strength and is Euro Class A1 non-combustible. We can offer you tapered roofs on balconies, terraces and walkways. Provide us with the plan of the roof, and we'll basically design it once we understand where the water runoff and outlets are on a roof, and we will look at that for you. We have standard angles of inclination, but we can do others on specs, and we can do tapered roofs as we will on DWA with a green roof application, or paviers, or various other systems and solutions, which I'll come to in a moment. Here's a case study. This is, in fact, I believe, a platinum LEED rated building that we did some years back now from Umdala. It's Cleveland Clinic in Abu Dhabi. And this was used in what we call an inverted roof, where the membrane is below the insulant, with paviers and slabs above. And there's approximately 9,000 square meters. You may well know of the project. Another project which myself and my colleagues completed, well, almost completed recently, was the Oman across the Aegis Museum. This was a project specified for the late Sultan, which unfortunately didn't get to see completed, but it is a signature building in Nizwa, so it's in the middle of Oman. It's approximately 87,000 square meters of foam glass, which will house some of the highest value products owned by the government and the country of Oman. And the reason we were selected was longevity, durability, maintenance, and the express protection that we gave to those artifacts within the building. We don't want fires. We've seen fires in South America, European countries, in museums. If you lose the contents of a national museum, it is a disaster. So they selected us for this. The project is actually cloaked in Omani marble. So to give you a build-up, the architect approached us and said, we want no penetrations through the roof construction. I do not want any damage to my waterproofing membrane, which sits on top of the concrete deck. They're absolutely paranoid. Oman has, when it rains severely. And some of these roofs are at 17 degrees pitch. But ultimately, the client and the owner wanted a product that was factory mutual approved. So their insurance was minimized, and the cost of insurance was minimized. And I see more and more people moving towards FM standards on buildings because of the concern of fire. And also, if you're the building owner, it's a big consideration going forward for the longevity of the product. So we used a concrete substrate, bituminous primer, foam glass ready block, which was sealed in 2 layers, a torch applied membrane, booze on pedestals which carried the Omani marble. Okay, and you can see the marble slabs there. This is a quick installation method to show how a foam glass compact roof is installed, okay, and installed in layers. Obviously, we're staggering the joints. As you know, as I said, the foam glass is completely impervious to water and water vapor. So over time, there can be no condensation buildups in the roof. We use hot bitumen an old product, but a great product. As I showed on the earlier slide, it has an extremely high mu value. Here you can see the installer dipping the edges of the boards into the foam glass on the grunt. As he pushes it in place, the foam glass rises between the joints of the board and provides a full seal between the boards. Hence, we call it a compact roof. So here you have various layers, in essence, of waterproofing before we get to the actual waterproofing layer. It was an interesting project, Oman, as I said, A, because of a very large area of roofing and wall, and the client wanted the roof to run into the wall and vice versa. So he literally wrapped the envelope of the building in foam glass to comprise a complete envelope solution. What was, however, more tricky was those Omani marbles, A, because of their weight, and B, because of their design. We needed approximately 6 pedestals per metre squared, and the question we had was how could we secure those Omani marbles on a 17-degree pitch without any mechanical fasteners going through the construction? There was no other way of doing it other than going back to the construction for other products. Here you'll see the engineers striking a line, and what they're doing is they're laying the roof out to capture galvanized fixing points for the pedestals that will then support the Omani marble. And in fact, this is a system we developed for hard metal roofing with copper, zinc, aluminium and stainless steel, and is widely used. I'll show you some projects shortly. You can see the plates being driven into place, okay, and they're secured. We torch a membrane over the top that has a dual action. It helps to secure the plates, but also seals any voids between the foam glass boards that are below. You have a homogeneous, compact roof, where in essence there can be never any moisture within the construction. Therefore, it takes out any of the jeopardy. Okay. The roof in this case was an installation team that we trained on site, so local labour in Oman. We had 4 teams installing approximately to 120 to 150 metres per day. And then it was very easy to oversee the quality. As foam glass, we attended site on numerous occasions, just to give that quality assurance and check. And to be candid, the labour with training was as good as any labour that I've encountered in Europe. And the job went really quite well for us. So an example, I spoke about a similar construction with metal roofs. For any of you guys, people that have been to Abu Dhabi and seen this building, this is the Officers Club in Abu Dhabi. In fact, this was a refurbishment of a Calzip style roof completed in 2006. The original building was swimming pool and various areas with polyurethane insulation, and the polyurethane failed. When Roger Talabé came to refurbish it, it was decided to use it in foam glass with a standing seam solution. Again, why? Well, why? Because there are no penetrations through that insulation, as you can see in the graphic on the right. No mechanical fasteners required, no risk of corrosion of fasteners. Everything is sealed. Should there be the slightest bit of moisture ingress, it can't get past the foam glass. And so there can never be a build-up in the roof construction. As I say, one of the major issues we have in the region is not using the right stainless steel fasteners, which is a topic in its own right. And zinc-coated steel is not good enough in high saline, humid applications. A couple of examples here. You can see how it works on a metal deck solution with that plate. The NATO headquarters building is a stunning building that was done with a zinc roof. And then in Azerbaijan, it's a very rigid insulation, 600-700 kilonewtons, where we are actually able to take curves and detailing with the product, which again, we don't need mechanical fasteners. Everything is bonded. So it's quite easy to take those shapes and curves and form it. This is an example of the DEWA headquarters building. So concrete substrate, bituminous primer, ready block glued and joint sealed, bituminous waterproofing membrane, EPDM, SBS bottom top layer, drainage with a buffer layer. And the idea will be that when the water falls, in Europe now we're moving more towards blue roofs, which means we're trying to hold the moisture on the roof rather than shedding it through the drains and losing the vital water. So we now have a buffer which would hold 40% of the water within the roof buildup, and then the remaining water is stored in tanks, allowing a slow infiltration. Critical reason for selection on DEWA is it will probably have one of the biggest arrays of PVs within Dubai, and we have to be very conscious of fire and the use of PV arrays. So Foamglass is factory mutual approved, A1 rated material that will never combust, gives off no toxic fumes or smoke, and therefore it was selected in conjunction. The other thing will be heavy loads on these roofs moving around afterwards. On a green roof, you need to be sure that your waterproofing membrane is there, because as we know with all plants, they'll do whatever they can to find whatever moisture is around. And the roots can be really quite aggressive, especially for us in the MENA region. A new product for us is inverted roof with an A1 system. We have a concrete structure, waterproofing membrane, new Foamglass inner therm, and the slabs are loose laid with dry joints. We then on top use a WRF layer, which is a water flow management layer, which actually minimizes and slows down the speed of the moisture ingress to the waterproofing layer under the insulation. And then we can put pedestals on top of this. As you can see, roof balconies, roof terraces, the desire to use every acre of space because space is of premium. And we're seeing a lot of move towards sort of foot trafficked activity roofs, as we call them. Now let's run back to the facade. One of the issues with facade engineering that we had on Oman was the number of penetrations. Can you see the amount of bracketry there and the amount of brackets that are required to support stone, timber, metal cladding systems? That is also in addition to the number of mechanical fasteners that are required to support and hold back the insulation in place. And what that actually does in terms of Europe, we would talk about cold bridging. One of the issues we have is we're trying to chill buildings in our region, and there's a risk there of the moisture and a condensation dew point being formed. And it is where that interstitial condensation occurs. A wet insulant has no value. And consider a mineral wool. You saw its mu value. It will allow moisture to through it, so it is breathable. But if it's constantly saturated with moisture and humidity and never dries out, it has very little property as an insulant. Okay. So what we did, we took the roof system in principle, transposed it to a wall. So here we have a concrete structure, could be a METSEC lightweight steel construction as well. Put the Foamglass on the outside. On the right-hand graphic, you see the plate, similar to the roof plate. One mechanical fastener through that plate, then carries the supporting rails, helping hands bracketry, which will take the stone facade. But also we've sealed the Foamglass boards, so any moisture that might get driven through driving rain can't get past the Foamglass insulation and therefore places no jeopardy. The Foamglass can't get wet, so the thermal value of the Foamglass insulation remains consistent. To show you an example of, well, in the UK, we obviously have had some big issues with fire post-Grenfell or Grenfell. I'm obviously aware of our situations in other part of the world. So Foamglass, we conducted a full Nfpa 285 fire test to show the performance of the product in a built wall situation. And if you guys have not seen a fire test before, I trust you'll find this of interest. It's a brief video, but I'll let some of the wording do its own talking. So you can see there the bracketry and support rails secured with one mechanical fastener, and then the cladding elements are hung on the face of that. Okay, so we wanted to see how a ventilated facade would perform. This was a basic construction. So we have a ceramic facade on a weight of 45 kilograms per meter, and then a metal support system with cement boards which are 15 kg. The Omani marble weighed considerably more than that. Okay, so that is the chamber that we fill with timber, in principle to provide the fire loading, which is constant. Okay, so it's not a source that we present and then remove. And you can see how quickly level 200 degrees C, timer on the right, obviously we've expedited this for the purpose of the presentation. Level 2 gets to 600 C. In an Nfpa fire test, what you're looking for is not the transmission of the flame up that zone. We have thermal couples behind it. We're measuring what is happening if flame is spreading. So there you saw no passage of the flame up the building. The metal brackets and support rails are still in position. We have some superficial cracks where it's 1,000 degrees C, but trust me, I've seen ACM material doesn't last 2 minutes in those sort of temperatures. And there is no damage to the building interior structure or external substrate. This is interesting. Look at the heat gain. It is only 10 degrees C behind that foam glass insulation. Imagine the protection that would augment to a building with fire teams inside. Okay. Okay. So to give you another example, and to talk about our ability to take form and shape, this is an interesting project in Graz with an open clad acrylic system, and look at the complexity of the curvature. And we were able to do this by faceting our slabs, which come in smaller elements. We can cut them, and if necessary, we can even rasp the material together to take a curve and a form well. So this is an interesting project just to show, you know, you think if you had a sample in front of you, you couldn't bend it. Well, you don't need to. We can take the curve and form those details. Foam glass pencil, I suppose, is more of a product for the European market. It enables you to run the floor insulant into the wall insulation. And because of the unique compressive strength of foam glass, we literally treat it as a building brick within the construction. So traditionally where you would have a cavity, you would run the insulation through, but your inner leaf of wall can sit upon the foam glass and be built up with no deflection and no loading. That does enable you to deal with one of the worst thermal bridging aspects. It's also quite important when tanking basements and thermally insulating basement areas. Okay, the Pencil 8A allows that continuity of insulation. It's laid in a soft bed of mortar, just like a brick. Okay. So, to summarize some of our case studies, and I believe we're currently working on the extension to, the next extension to the Grand Mosque, with 100,000 square meters of foam glass was used. The Museum of Islamic Art in Qatar, again, on flat roof with supporting pedestals, and in the National Museum of Qatar with the Jean Nouvel product that we worked on. Unfortunately, dear Nfpa is no longer with us. Okay. As a company, we offer you project-specific design support. We can do thermal and dew point calculations. We will assist with material installation data sheets. We give a complete service of technical data sheets, project installation guidelines, and specification write-up for you in CSI, MBS. We can also offer, in light of this presentation, we're American Institute of Architects accredited, and also the Royal Institute of British Architects training. We will do on-site installation training, as you saw there in Oman. It's one of the critical factors to our product to ensure that the material is used correctly and installed correctly. That is how we are able, if asked, to give a 50-year warranty on our product, that the product will stand. We have that test of time, and we believe that that is a strong thing behind us. In essence, that is my presentation as stands. Can I just ask the moderator how we wish to proceed with Q&A, or what we would like to do?
Yes, we will ask everyone now to share their questions. Thank you for the presentation. Okay. So everyone, if you have any questions, please share it now. Okay, this is a question from Sean. Can you please explain about Pest Proof? Do you have the experiment for the experiments?
The proof that we have for the experiments, yes?
Yes.
Okay. The experiments are conducted internally, and those experiments, to be very candid with you, are very old, as you may have seen from the graphics and the videos. We do have full certification and testing on our materials, okay, and to see how they compare with other products. So the vapor transmission that we showed initially is done at an in-house testing laboratory, but we can validate all of these statements. Foam glass is unique. It is made of a cellular construction. If you took a microscope to it, you would be able to see the small glass cells within it. And as we all know, the only two things that don't allow vapor transmission are basically glass and steel. So I'm happy to share those contents of those tests within reason, and we show them to graphically represent what happens. You know, we're not here to be denigrating to other people's materials. We believe we have a superior high-grade product which is ecologically sound. That's where we come from. In terms of the life expectancy, those are reports that we will talk to people about. We can share that information. We've gone back and tested buildings that are over 50 years old. That's the other thing. Unfortunately, like me, it's quite an old material, which means that it's been used in a lot of applications.
Okay, we have another question from Abdurrahman. Thank you for the presentation. Do you have transparent product of the foam glass?
That's quite an interesting one. Historically, Pittsburgh Corning used to produce, are you ready for this? Glass blocks. Okay. You're probably aware of old glass blocks from the 70s and 80s that we actually manufactured those. We've stopped the production of those. Unfortunately, as an insulating product, we can't produce a clear product. The reason for that is we put a product in called carbon black, and it is that acts like the rising agent. It's a little bit like putting yeast in bread. So my apologies, we can't. It's somewhat unfortunate, but if we could crack that, we'd have a great product.
Okay. Okay, we are waiting if there is more questions.
Okay.
Okay, there's another question. Is there some product design but some designers use that materials? It may be Michael Young. Okay, this question is not clear. I think Sean, if you can rewrite the question because we didn't get it. I will try to read the question again. Do you know any familiar designers who use the material already in, let's say, worldwide or MENA region?
I suppose I hate to use the name, but Foster and Partners, Darla Henderson have used us widely. We've done we work a lot with European architects, but in Dubai we're also working with local practices. So I suppose our big one is Foster's. We've worked internationally with them as a practice. We're currently involved with them on several projects in Qatar. You saw the Jean Nouvellis project as well, which was the new museum of Qatar. And they specified foam glass there because of the fire concerns. Also, the project in Oman was done by Cox Bailey Howlett, who are an Australian practice. So, yeah, I mean, we're an international company. We're present in most countries around the world, obviously headquartered now in America. So we do a lot of work with American practices as well.
Okay, another question. Could you please shed some light on load-bearing applications?
Yeah. I mean, I suppose for us, in essence, if we're talking a car park deck, a traffic area, or such a thing as a helicopter pad, where you have intense load, but so when we still need a separation layer, okay, so to dissipate the spread, foam glass itself between 700 and 1600 kilonewtons. So you can literally drive a bus over it. I've recently done a project which was an entry lever over a building where they needed to bring fire trucks in and out in the event of an issue. and they selected Foamglass Cellular glass. Many years ago, I did the concourse to the tunnels at Heathrow Airport. So we actually had a runway running over the top of the insulation. It used as a void filler because they weren't prepared to put anything else into those ones. But happy, however we want to deal with this, but we obviously have a complete sort of technical literature on what we think is a very good website. If you have a specific application, you saw the extension there to the Grand Mosque in the walkways. Foamglass was used there, and we're seeing more and more of a use of trafficked roof areas. And really, you have to be considered when you start to do that. So the compressive strength is critical. In liquid gas applications under liquid gas tanks, you have a heck of a lot of loading, but the product has to remain at a consistent temperature. And Foamglass is the only product that would be specified in those applications. So yeah, but also we're happy to support you as the architectural community. If you have a particular project or an application that you're trying to use, we will work with you.
We have another question. Can you do GPA calculations such as CRS, etc.?
I can phrase that very quickly. Yes, we can. Yeah, we're happy to assist you with all forms of well, within reason, all forms. Yes, of course, we do those, and that is part really of what we do, because insulation is insulation. I think I tried to express earlier for MBT and Tectonic. One of the reasons we formed was to try and provide system solutions to help not just give you the insulation. How does this insulation act if it's put in conjunction with X or Y? And I personally believe, of my experience of Dubai, the fire and life safety codes, and in Europe, the move towards, I suppose, validation of the complete wall construction. Post-Grenfell, I think you will see a lot of changes. And yes, to be able to do all of those calculations is good. To be able to do all those calculations in conjunction with other products is even better. So we can provide you a through-wall selection. Like on the Omani project, had we not been able to do what we did with Foamglass, there would have been so many cold bridges on the roof that the insulation factor in a mineral wall, XPSs, would have been even thicker. It's quite interesting, the impact of that has. So yes, we're happy to help with those calculations. My colleagues aren't, I don't know what we can see on the screen at the moment, but we have colleagues, an engineer, Kamlesh, that can help, and a full technical support operation.
Actually, he's firing us with some questions also.
Okay, that's what's worrying me.
Okay, we have a question. What kind of glues do you propose for bonding insulation or to substrate? Okay,
well, that very much depends on the application. I'm not trying to dodge that question. We work with, I mean, historically, we always used a bituminous-based type adhesive. One of the reasons for that, as you saw at the start of the presentation, it has an incredibly high mu value. So its vapor resistivity is very, very high. And if you're putting a product like Foamglass, which is infinite, next to it, it's good to go that way. But we are also developing new products which don't use bitumen, more organic compounds to enable us to bond the insulation. And I suppose in a little way why we've moved to an inverted roof application as well, to take away the need for the glues and adhesives. But again, if you have a specific project, we can recommend products that aren't bituminous based. Yeah, I'm sort of slightly swerving it because it's quite a long list that we could deal with on a project by project basis.
Yeah, well, I think these are all the questions that we had so far.
Okay.
We will wait just 1 minute maximum if anyone have more questions, and then we can wrap up. Okay. During that, is it possible to share this presentation with us so we can share it with the people, with attendees?
Yes, I think there's no issue with that. We have nothing contentious in this.
Also, you mentioned an email. You mentioned a website.
Yes, I will share all of that. I mean, what we can do is provide you with the presentation and then all the pertinent contact details for the region.
Yeah, perfect. Thank you.
Okay, that's good.
Okay, I think we will wrap up.
That's
The
fine.
questions are up. I had to turn off your camera because the internet went down, so the sound
sorry.
was glitching. So I had to turn it off. So
No,
that's fine.
no problem.
Thank you again for the presentation and for His Royal Highness and for your team, actually, with the big support that we had on the talk today and everyone who attended today with us.
Thank you very much indeed. It's been an absolute
Thank you,
pleasure,
Mr.
everybody.
Bauer.
Have a good
Thank
evening,
you.
everybody.
Good evening.
Goodbye now.
Thank you.
Bye-bye.
Take care.
Bye.
Bye.